Non-repeating decimal, which again cannot be written as a rational number. One integer over another. Rational number. Blah blah blah. One integer over another. Blah blah blah. Oops. One integer over another integer. And yeah, when you do, hold on, I forgot what it's called. Okay, so non-repeating decimal real quick. So you see how you can actually, oh, not this one. In this one, you can solve for x, you can solve for x, you can solve for x. But, real talk, I'm just doing this for myself. So if, like, I skip some things, I might be advancing to some things. It's easy to follow, but, actually, I'll just say it all later. Okay. Well, let me go back to this. If you're solving for x, it's like possible to solve for x with a decimal, possible to solve for x with a decimal, possible to solve for x with a decimal. But with pi, you can't do that. Pi goes on forever, forever, forever. With pi, this problem would never end. And that's what it. So, this is a terminating. Because after all these decimals, you would eventually find a answer. But with here, this is non-terminating because pi goes on forever, forever, forever. Sometimes when you're solving for x in a linear, what do you call it? This is an inequality equation. You're going to come across problems that are just infinite. All right, that's it. All right, real numbers are equals x. X corresponds to the point on the number line. X corresponds to the point on the number line. X corresponds to the point on the number line. Any number that belongs to either the rational or irrational numbers will be considered a real number. Rational, irrational numbers, real number. Rational or irrational. Hold up. Okay, cool. Rational, irrational numbers will be considered a real number. That would include natural numbers, whole numbers, and integers. So real numbers are literally everything rational, irrational. Subset, real numbers. Subset, real numbers. Subset, real numbers. So both of these combines, real numbers. Both of these combine, real numbers. Both of these numbers combine, real numbers. Real number line. Negative, positive, origin. Okay. Real number line, real number line, real number line. Negative, negative, negative. Positive, 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 origin, origin, origin. Negative 1, 2, 3, negative. Negative 1, 2, 3, negative. Negative 1, 2, 3, negative. 1, 2, 3, positive. 1, 2, 3, positive. 1, 2, 3, positive. Origin 0, origin 0, origin 0. Above is an illustration of a number line. 0 on the number line is called the origin. It separates the negative numbers located to the left of 0 to the positive numbers located to the right of 0. To the left of 0, to the left of 0, to the left of 0, to the right of 0, to the right of 0, to the right of 0. I might just repeat some phrases because they're like vocabulary phrases. Like, these are two phrases. Even though like it's easy to know what it is, you need to know the whole phrase. Hold on. It's just a phrase of words that you should know. So, phrase of words, phrase of words, phrase of words, and it's gonna like you're gonna see it a lot. So you should just memorize those phrases. I feel sorry for 0. It does not belong to either group. It has neither a positive or a negative number. Order property for real numbers. Order property for real numbers. Order property for real numbers. Given any two real numbers, A and B, if A is to the left of B on the number line, then A is less than B. If A is to the right of B on the number line, then A is greater than B. So left to right. So exactly how you see this, this is the order, the order, the order. Less, 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 less. Positive, positive, positive. Less, 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 more, more, more. 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 Oh, where am I? Absolute value. Absolute value, absolute value. Most people know that when you take the absolute value of n